హలో ఎవ్రీవన్. పబ్లిక్ ఎగ్జామినేషన్లో క్వశ్చన్ నెంబర్ 18 మనకు ఫంక్షన్స్ టాపిక్లోంచి ఒక 7 మార్క్స్ క్వశ్చన్ ఫ్రేమ్ చేస్తాడు. ఎవ్రీ ఇయర్ మోస్ట్లీ ద క్వశ్చన్ ఫ్రమ్ థీరమ్స్ ఆన్ ఫంక్షన్స్ టాపిక్ ఆర్ అదర్వైజ్ there are two more problems based on G circle of whole inverse equal to F inverse circle G inverse, and one problem based on injection. Let us see here the first theorem. Prove that F A to B, G B to C bijections, then G circle of A to C also bijection. This is the question. Yes. To solve this, what I am writing, observe. First I am going to write given data. Yes. See the proof of this. First I am going to write the given data. Observe here, F A to B, G B to C are bijections given. Yes. First statement here I am going to write. Given that F is a function, it is mapping from A to B, it is a bijection. Also given the other condition, G from B to C. Yes, here I am going to write, given that G from B to C is also a bijection, right? Next, here we need to prove that G circle of A to C also bijective. Yes, here I am going to write we have to prove that G circle F A to C also bijection, right? Yeah. Next, bijection means the function is both 1 as well as onto, or you can say that injection as well as surjection. Yes, since bijective I am going to write 1 and onto. Two conditions I am going to mention in the proof. Yes, first one, yes, bijection implies I can write F is both 1 as well as onto, and the same here I am going to mention the function G is both 1 and also onto. Here the aim is to find bijection, so that first we need to prove that G circle F A to C 1 and then we have to prove that first G circle of A to C 1 we need to prove, and second one G circle F A to C onto, second condition also we need to prove. If you prove these two results, then you can say that the function is bijective. Yes, the last statement, if these two conditions are true, then we can say that F A to B, G B to C, these two are bijections implies then you can say that G circle of A to C also bijection. Yes. I am going to write 1 1 and on 2 conditions. Now you know that 1 1 definition, mathematically we can say that theoretically different elements of A suppose associated with different elements in B, then we can say that the function is 1 1, and mathematically you can write f of a1 equal to f of a2 implies a1 equal to a2 for all a1 a2 belongs to capital A. First I am going to write 1 1 condition. Yes, f suppose 1 1, if you can write f of a1 equal to f of a2 implies a1 equal to a2. This is true for all a1 and a2 belongs to its domain. 1 1 condition over. Here first I am going to write 1 1 condition to G. Yes, G11 if and only if. Here f is defined from A to B, so input from capital A, so that the elements are small a1 small a2. G is defined from B to C, and entries in the set B written as small case letters B1 B2, so that here you have to write the definition G of B1 equal to G of B2 implies B1 equal to B2 for all B1 comma B2 belongs to first set. 1 1 condition over. From these two 1 1 conditions you can prove G circle of A to C 1 1. Let us see. To prove G circle of A to C 1 1, first you need to select G circle F of A1 equal to G circle F of A2. From this we have to prove that A1 equal to A2. Let us see here. This is composite function, so that it can be written as G of F of A1 equal to G of F of A2. Yes. Inside G, F of A1 here, F of A2 there, but both are same. Suppose G of B1 equal to G of B2, then the input must be equal due to 1 1 condition. So inside the G you have f of a1 f of a2. Since these two are equal, I can say that their inputs are also equal, f of a1 equal to f of a2, using this condition. Next, here I am going to mention, since the function G is 1 1, input elements also equal. Next, f of a1 equal to f of a2 you have, and from that you can write a1 equal to a2. Here a1 equal to a2 you can write by f11, since the function f is 1 1. So G circle f of a1 equal to G circle f of a2 implies we got a1 equal to a2, and hence I can say that the function is 1 1 function. Yes. So I can conclude here. Therefore, yes. Therefore, f G circle f, right? G circle f A to C is 1 1. Whatever the input given to the composite function G circle f a1 and a2, if they are equal, then inputs are also equal, so that 1 1. F of a1 equal to f of a2 implies inputs are equal. G of b1 equal to g of b2 implies inputs are equal. From these two conditions you got G circle f of a1 equal to G circle f of a2 implies a1 equal to a2, and hence it is 1 1. Next, I am going to write on two condition. You know that theoretical definition, if codomain should be equal to range, then we can say that the function is onto function, and mathematically we can say that for all small b belongs to capital B, there exists small a belongs to capital A such that f of a equal to b. This is onto condition. Yes, this is the condition when f is onto. I am writing here f onto if and only if this is the condition. Since f11, since f onto. Yes, here since g11. Now, since g onto, if and only if I can write for all g is defined from b to c. So, for all small c belongs to capital C, there exists small b belongs to capital B such that the value of g of b which is equal to c. Suppose that this is 1, this is 2, and this is 3, this one is 4. 1, 3 are, this is first one and this is third one. 1, 3 are 1, 1 conditions. Next, with the help of these two onto conditions, I can prove that G circle of A to C also onto. Here, when F A to B onto, the statement here you have to start with for all B belongs to B, there exists A belongs to A such that F of A equal to B. So here, for all small c belongs to capital C, there exists small a belongs to capital A such that G circle of f of A that should be equal to C. Let us cross check whether it is equal to C or not. G circle f of A written as G of f of A. What is f of A? F of A, f mapping from A to B, and f of A is B. So that input B. This is by f onto. Next, G of B equal to C from G onto. That is from second result and from fourth result. Or, okay, onto or from 2, 4. So, both G circle of 1, 1 as well as onto. You got G circle of f of A value C. Therefore, G circle f A to C is onto. And here you need to write the condition for all A1, A2 belongs to capital A. This is true. Yes. From 1, 1 conditions, 1, 1 proved. From onto conditions, onto is proved. So, G circle f is both 1, 1 as well as onto implies, I can say that finally G circle of A to C is also bijective.